Welcome everyone to the Helm Deep Dive. My name is Paul and this is Scott. Scott, why don't you introduce yourself?
Great. Hey, I'm Scott Rigby. I am a Brooklyn-based artist and software engineer who is also part of the Helm team. I help with Helm charts and I help with related automation and tooling and also with Helm governance.
My name is Paul Czarkowski. You can find me on Twitter at pczarkowski. I'm a Helm charts maintainer. I work at VMware and I am one of the hosts of Tanzu.tv.
Cool. Just so you all have a mental progress bar of this short chat, we've just discussed who we are. We are going to describe Helm at its current version, Helm 3. We'll give you a few notable announcements. We'll be talking about important things that you probably want to know that Helm does functionality-wise, and the tools in the community, the wider ecosystem. We're going to cover Helm security, and finally, ways that you can get involved with the Helm community. So in case you missed it, the current version of Helm is Helm 3.
So if you're on Helm 2, it is way past time to upgrade. Helm 3 is nearly a year old and has made some major changes. Things we'll be talking about will be focused on Helm 3. It is easy to upgrade from Helm 2 to Helm 3, both on your laptop, but also in your Kubernetes cluster. Helm 2 charts will continue to work in Helm 3. We are backwards compatible there. So all of your existing charts will continue to function. Most of the differences are architectural and in the software itself. The big difference, of course, that everyone likes to applaud at is there is no more tiller. So we have a Helm 2 to 3 plugin, which is provided by the Helm community, which does most of the work. You just need to make a choice. If you want to follow the strangler pattern and slowly replace releases, or if you want to do like a full in-place one-shot upgrade. So this is the Helm 2 to 3 plugin. It's really simple. You can see from this screen, Helm 2 to 3 convert Postgres will upgrade your Postgres release to Helm 3. But rather than just showing you this, why don't we actually kick off and give you a demonstration to show you just how easy it is to upgrade a cluster that has a bunch of Helm releases installed on it. So Helm 3, or just Helm, has been out for at least a year now. And so it's time we just let go of Helm 2, right? I don't want to even talk about Helm 2. And so the way we do that is we get everyone to migrate from Helm 2 up to Helm 3. So as a community, we have put together documentation, blog posts, and tooling to help you migrate from Helm v2 to v3 and get tiller out of your life. I'm going to take you straight to a command prompt and demonstrate just how easy it is. I have Helm 2 and Helm 3 as separate binaries, so we're going to run Helm 2 version. So we want to see what releases are running, and you can see we've got 4 applications running in our cluster. And we want to migrate from Helm 2 to Helm 3 without disrupting these. And that's where the Helm 2 to 3 plugin comes in. So we're going to go ahead and install that plugin. So let's do a dry run conversion of one of our releases. And we do that by doing Helm 2 to 3 convert. We'll choose discourse and we'll do a dry run. And you can see that happen really quick. I feel confident now that I can run this across my cluster, across all of my releases. So we're getting the Helm 2 output and we're passing that through to Helm 2 to 3 convert. And you can see this runs through pretty quick. And we're already complete. We want to verify that we're complete. So we're going to run Helm 3 ls all namespaces. You can see our release data is now available to Helm 3. Let's take our Helm 2 config on my local workstation and convert it into Helm 3. So now, finally, we want to clean up tiller. And this will not just clean up tiller on the cluster, but it's also going to clean up Helm 2 on my workstation. So Helm 2 to 3 cleanup. We have now removed all vestiges of Helm 2 from our lives.
Great. Now for a few short announcements. One of the biggest announcements is that Helm has graduated from CNCF incubation to a graduated project.
Hurrah!
Yay! We'd like to thank everyone who got us here, specifically the Helm core maintainers of Helm charts, many of whom have worked tirelessly to support the community charts for so long. Also the various Helm project maintainers. There are projects within the Helm organization, including Chart Museum, the Helm Hub, which is based on Monocular, also maintained by the Helm team, Helm plugins, and also the Helm org maintainers who help with governance and things like that. And finally, the rest of the community, everyone who has contributed to community charts, various Helm issues and pull requests, and all of the users who helped make this a great project. So thank you very much.
Due to unprecedented events this year, we have extended the deprecation timeline for Helm 2 and also for the stable and incubator charts repos. Bug fixes were extended until August 13th this year and will be officially deprecated on November 30th this year. So those are important dates to remember and will help you plan for when you do your Helm 2 to Helm 3 upgrade.
And you might be asking yourself, where are the stable and incubator community charts going to be hosted now if they're to be deprecated? How are your projects going to continue to function if you require those? Community charts are now moving from the previous stable and incubator repos to a more distributed model. Those distributed chart repos are all aggregated in the same way. So if you're worried about how am I going to find my charts, it's easy. You can find them now aggregated at Helm Hub and Artifact Hub. Artifact Hub is likely the successor to Helm Hub, and so many Helm repos are publishing to both at the moment. The actual source code for the charts primarily is being adopted by the maintainers of the software that's installed by those charts. This issue here on the screen, and you'll see a link later at the end of this talk, can help you keep track of the progress of moving those charts from these repos to their eventual homes. And if there are charts that haven't been moved and you really care about this, you work for an organization or you're an individual and want to group together with others who want to help take ownership of that chart, then please do so. Open an issue and we can work through that process together. Additionally, there's an excellent collection of curated charts by friends of Helm, Bitnami, who have worked also tirelessly on the community charts in the past. Those charts have been in the Bitnami repo for quite a while. They were just mirrored in the community charts, and now they are the source themselves. So you can still see those where they were, and now you can make PRs directly against those repos. This is helping the charts maintainers to spend more of their time working on the tooling around Helm, the best practices guides, and so on that we've been doing, such as charts testing and charts releaser tooling. This can be used for community members who want to host your own distributed Helm repos that are aggregated by the Helm Hub we just mentioned.
So chart testing is a tool that automates the testing of your Helm charts inside of Git repositories. So when you push a change to a Helm chart up to Git, it will detect which charts have changed inside of your repo, and then it will perform linting and test just those charts. Chart Releaser will release charts to a self-hosted Helm chart repository. It effectively helps turn your GitHub repository into a Helm chart repository. So it creates chart packages, it uploads those packages to GitHub releases, and then it updates the index in GitHub pages.
Chart testing is what we use in community charts today. Chart Releaser is not being used in community charts primarily for legacy reasons, but many chart repos are using it today, and it's recommended to use. We also have GitHub Actions for Helm charts. These actions essentially wrap what Paul was just describing, so that if you are using GitHub for the source code for your charts, pretty much all of this is automated for you. You just have to do the configuration, and then they have very same defaults as well.
How about we just show folks how that works? Creating a chart is just that simple. Let's change to a branch. And we'll add our chart to the repo. All right, and we can grab this URL here and open up our favorite web browser. So we've created the pull requests, and you can see we now have an actions kicked off, lint and test charts. So all you need to do in order to enable this in your charts repo is copy this GitHub workflows. So we have one workflow for lint and test, and you can see it's pulling our chart testing action, and it will actually create a kind cluster and install your chart. And then we have our release. And this will happen when we're merged into our main branch, and that will run our chart releaser action. It will actually create the package. It will create a release in GitHub and upload that package to that release. It will then update the index.yaml file in your GHPages branch. So let's have a look at that action and see how it's going. So you can see it's running. For the sake of time, let's assume that it has worked and we're now ready to merge. So let's go ahead and hit the merge button. Then we'll see the second action kicking off. And this is the release action. And so it's going ahead, it's seeing there's a new chart, it's packaging up, and it's uploading it. And it is done. So now here under releases, you can see we have a new release. And this is named for the chart, and it has our chart package. If we switch to our GitHub Pages branch, you'll see we have an index.yaml. And if we search for KubeCon, you'll see that this has been updated for KubeCon. Therefore, we should be able to go ahead and install it. So let's add our repo, do a repo update, and attempt to install our chart. And there you have it. So we've installed the Helm chart that we just created from our very own Helm chart repository without having to do any real work because we have the GitHub actions to do that for us. And for more announcements, you can always go to the Helm blog at helm.sh/blog.
Okay, now we're going to cover some functionality that many people don't know about Helm.
Yeah, things that are either new in Helm 3 or just aren't well known. Scott, tell us about how the chart.yaml has changed.
One note is when you're perusing community charts, many charts are still in the chart API version 1. That was the version of Helm charts that Helm 2 created when you implemented the Helm create command. Using the current version of Helm, it implements Helm charts API v2. The major version bump was to allow additional functionality afforded by Helm 3.
We added a type field so you can identify whether it's a standard application chart or a library or common chart. Library charts provide you a way to put reusable functionality and definitions in a chart that can then be reused by other charts, allowing you to keep your charts as dry as possible. We've also moved dependencies into chart.yaml, and we've removed the requirements files. That was just for consolidation and cleanup and having less clutter in your chart. Scott, why don't you tell us about the new...
Yeah, Paul. So this is one of the exciting features that Helm 3 provides as well. Many people have asked, is there a way to validate values? And there have been various hacks and tools to help make that happen, at least within an individual organization, so that developers can have consistency and minimize errors. The Helm team introduced the ability to validate values passed to a chart built into Helm itself now. So you can use JSON schema to help make sure that happens. The way to do that is to make sure that there's a values.schema.json file inside of your charts folder. And this gets run on Helm install, upgrade, template, and lint. So that if someone were, for example, to pass a value that didn't match the type that you defined, it would give you an error early and you wouldn't have to go tracking it down later.
And that's super important because we all know that YAML is not typed. And so being able to put some typing in there is really great.
Helm comes with a test framework, so you can ensure the stability of your charts as well. The way that you do that is you can install one or more values files inside of a CI directory inside of your chart. Each of those are run during Helm testing so that you can test various use cases.
You can also add very specific tests by creating resources with the Helm test hook annotation, which will ensure that they're automatically installed on test and cleaned up for you, but will not be installed on a regular install or template. That tied together with your CI test values gives you a lot of flexibility to perform integration tests as part of developing and deploying your Helm charts. So we also added experimental support for OCI registries. However, it is incredibly experimental. Feel free to play around with it, but expect it to break. We are waiting for the upstream OCI community to stabilize the APIs before we move on from calling it experimental in Helm. So it is disabled by default, and you can enable it by setting the environment variable Helm experimental OCI. If you're interested in OCI, you can run Helm help chart and Helm help registry and find out details on how to use it. And you can read Josh's proposal on how we support OCI from the above link. Scott, now that there's no Mozilla, how do we actually store what releases are installed on a cluster?
Releases are now stored as secrets by default. And the release information is stored in the namespace where each release is released. And the release information is now stored within the namespace of each release. Helm users can see this pretty quickly just by looking at secrets within the release namespace itself.
We've also made changes to how we deal with CRDs. Think of them as kernel level things as opposed to most applications that charts install, which are user space. So because CRDs are so crucial and so critical to the Kubernetes cluster, while we will install CRDs, we don't want to upgrade or delete them by default because that can really mess with your cluster. If you don't want to install CRDs at all, you can skip them with skip CRDs. Any CRD install hooks that we use in Helm 2 are now ignored with a warning in the new versions of Helm.
If you are using Helm to install your CRDs, as Paul mentioned, make sure that they are not templated. They should just be pure YAML.
That's right. If you do really want to install CRDs with Helm, you can template those CRDs and put them in the Helm templates directory. And you can even do that in a dependency chart and pull it in as a dependency. Our best practice is to not install CRDs as part of the installation of an application. Scott, tell us what's changed in the Go SDK.
Yeah, well, the biggest change is that Helm now has a Go SDK. All of the code has been restructured for a much better developer experience. Before, if you had ever tried to write your own code that leveraged Helm under the hood, you may have noticed that you had to rewrite a lot of what the CLI did. Now, the Helm CLI consumes the exact same SDK that your application would consume if you create one up from scratch yourself. And the packages that you can look at is make sure to look at the action package. There's the chart and chart util package. And finally, the wrapping CLI and all of the sub-packages around that. Just digging through the code, I think it's very readable and you'll have a pleasant experience.
And a perfect example of where we can see improvements with that is the chart releaser currently execs out to Helm package, whereas now we can actually call the package chart library within Helm through the SDK and do it directly inside of our application instead of shelling out. And so here's an example of how easy it is to use. This is a really simple Go application that is going to list the Helm releases in a particular namespace. Now, this is one of my favorite new features, the post renderer. It allows you to not only use Helm, but you can also tie in Customize or YTT or similar tools, and that allows you to take a Helm chart that someone else has developed and make minor changes to it or major changes to it outside of the chart itself. For example, if you just want to add labels or annotations, you could call out to HashiCorp Vault to fill out secrets or collect keys. You could even perform a security audit before you ever hit the cluster. So we have plenty of documentation on how to do it, but rather than boring you with more details, why don't we just show you a demo? So let's take a look at the post renderer. I've already created some assets to make things quick. So let's have a look at what we have. We have our post renderer script, and then we're using YTT, so we have some YTT files. So quick look at the post renderer. It's pretty simple. It's a bash script. It takes in standard in from Helm, which will be the rendered templates. It will pass them through YTT, and then it will output standard out, which will then go back into Helm, and that will become what is sent to Kubernetes on say a Helm install. Let's take a look at our YTT files. So we have a WordPress password. This is a YTT file that is going to look for the secret that contains the WordPress password, and it's going to overlay a different password on top of it that maybe we're fetching from HashiCorp Vault. But for the sake of the demo, we have a file in here, which is just setting it. So let's go ahead and run Helm template, and we'll just look at the WordPress password. If we add in the post renderer, like so, you can see we have a WordPress password like so. So we can pass that back through YQ and base64 decode it. And there is the value that we have set from our YTT. So that's the post renderer working. Now, of course, we may want to actually embed this in a Helm chart. So what would that look like? So we could have a Helm chart called blog. In its chart.yaml, we've set a dependency on WordPress. So here we could do a Helm template dot post renderer. So that will use the WordPress as a dependency, and we'll load it up. And therefore we now have a Helm template that looks like this. So you can see we have YTT there, we have our post renderer in a bin, and then we can do a Helm package. And there we have a package that we can then upload to our repository.
Yeah, I'd love to mention one thing. One of the big benefits that I see for the future of distributed Helm charts is that they can stay simpler now and still allow people to fulfill their edge cases without having to have pull requests that create if-else trees for every single use case under the sun. That increases complexity, and I think as many people have seen in community charts, it can lead to spaghetti code. This helps to keep them cleaner, potentially. So I'm looking forward to seeing that in the future. So now we'd like to introduce you to a few tools that extend Helm. There are a lot more than this. This is just a short list, but this gives you an idea of some of the common tools and also what's possible. One of the, from my point of view, indispensable plugins is the Helm diff plugin. This works for any client, both for the end user when you're imperatively running Helm commands, and for, let's say, even during the CI/CD process, where you want to look back and see, oh, what actually changed when I did an application of a new release? Helm diff can automatically spit out that diff for you and show you this is exactly what changed between releases. You can also use it to debug.
And then my favorite tool from this list is Helmfile. I use Helmfile a ton, and it is a great way to take multiple Helm charts and orchestrate them together as code. So it's almost like the Helm for Helm in a way. And it becomes really important when you start to have a large number of charts. I've seen what happens when you end up with like 15 to 20 dependencies because you're trying to install a bunch of stuff at the same time. Helmfile makes it much easier to do that without having to commit such atrocity.
If you want to have Helm releases in code in a GitHub format, you can use Weaveworks Helm controller that recently released. There are also other Helm controllers. This is just one example from the list of them. Or you can write your own.
And then there's ConfTest, which is a great way to test your Helm charts against OPA rules to make sure that your Helm charts are going to follow your best practices as described in tools like Open Policy Agent before they're ever installed to your cluster. So you can have that at the CI stage of your CI/CD of your Helm charts themselves. So that gives you that fast feedback of something is not quite right, even though it's not exactly an error.
It's a very cool tool.
And of course, Helm is very extendable. So if you want to solve a particular edge case that you have, you should write your own tool, open source it, and maybe next year up on stage, we'll be talking about it. And now for everyone's favorite topic, security. With Tiller removed, the main thing you need to be concerned about the provenance of your charts. Everything else is delegated to Kubernetes.
And to be clear, what is meant by that, you mean like with the idea of bad actors, for example, is just check the chart.
Yeah. Like, who wrote the chart? Is it the chart it's supposed to be? All that sort of stuff.
Right, exactly. Things like signing charts and so on. I wonder if we should mention the Hacking Helm session.
Yeah, because I think we kind of cover some of the chart provenance.
We definitely did. Yeah, I think
Yep.
like as in-depth as we could.
Yep.
All of the other security concerns generally are already something that you should be dealing with when operating with Kubernetes. So RBAC, PCP, what are your network policies? Do you have auditing? Are you signing your containers? And so on. We do cover many more in-depth edge cases and hacks in a previous session that Paul and I did called Hacking Helm. But for all intents and purposes, this is the primary difference now in moving to Helm 3.
So what you're saying, Scott, is that Helm basically just inherits your RBAC. So whatever security settings you have for your user in Kubernetes, Helm as a client just inherits those permissions.
Exactly. The Helm client can be used by a human, but it can also be used in the cloud. If you're a cluster administrator, Helm has full cluster administrator access. If you're limited to a specific namespace because you're on a team within an organization, your Helm client follows suit similarly.
Right, and so if you're like a read-only like Jenkins service account, then Helm is just a read-only Jenkins service account.
Exactly.
Scott, how about you tell folks how they can get involved in the Helm community?
There is an ongoing effort, as I mentioned earlier, to migrate or move or adopt the community charts into their eventual forever home. We had posted the link earlier, and please see it here again. Please get involved in this effort. This is very important because the Helm charts are what make Helm so valuable.
You can also use the chart testing and chart releaser tools and GitHub Actions to host your own charts. So that makes it incredibly easy to adopt community charts, whether it's you as a person who cares about a particular application or you as someone who works for a company that writes a particular piece of software. We make it very easy for you.
Yeah, and Helm as a project, as it continues to grow and people are expanding their own efforts, Helm is looking for new maintainers. So please connect with us on Slack and on the other channels, and let's see where you want to get involved.
You don't have to be a hardcore Helm chart maintainer or a hardcore Go programmer to be a valuable member of the Helm community. We're always looking for help with the documentation, with writing blog posts. Basically, whatever you're passionate about, we want to have you come and help us make Helm better in whatever way you feel comfortable. Scott, how about you summarize what we've just talked about?
Well, I think for a complete summary of our entire talk, we may be biased, but we think Helm is awesome and you probably should be using it. Did that sound convincing? I mean,
It sure did.
Okay. And as promised, here is the list of helpful links. Here is a link to the slide deck. So if you're seeing this in some channel that doesn't give you that link, that should help you get to the deck itself where you can follow our links that we've peppered throughout the presentation and gain further information. There's a link to the Helm docs. We also have the link to the migration efforts that we talked about before if you're still using Helm 2. An in-depth list of changes for Helm 3 for those who care. There's a link to Helm Hub, which will help you get to all of the existing charts. And if you want to quickly jump to our various tools, there's the list.
Well, that's it, folks. Thank you so much for attending our session. Hopefully you've learned a little bit about Helm. And if you want to join our community, please do. We would love to have you.
See you later.
Bye.